We got a, kudos to Rachel for giving us a slideshow that's got lots of animations and stuff in it. She does a pretty good job. I just build a basic slideshow. When I turn it over to her, she makes it really cool. And she does things. Kudos to Dave Hobbs. He's the one I got some of this information from. Some of it came from other places, so it didn't all come from Dave and all that. So the customer wants a smooth ride. And right now, they don't have it now. Whenever we were working on the Buick, the president's car out there earlier, me and Reeves drove it up the road, and we hit about 60 miles an hour, and we were getting, getting a little bit of that, and you're jiggling, you're feeling the seat of the car. And it had the tires balanced somewhere else, but anyway, we put it up, he put it up on the machine, and some of those tires, what'd you have 2.5 ounces on some of them or whatever? Sticky weights?
Well, one 3/4.
Yeah, and it was pretty, and what was crazy too, he also had originally set it up with a cone that looked like it would work right, but it didn't, and they were egging. And so you had to make sure that whenever you're spinning that tire, you look at it. Anyway, simple fact is, if you look under there, have you ever looked under and seen wires going to the shocks and struts? And want to know, what do I do with that? You know, if there's some kind of a problem with that kind of thing, I even wonder how they work. Well, this is Delphi. Now Dave, the guy that I was talking about earlier, he works for Delphi. He's one of their engineers, and he's a guy that I happen to have met in my doings and whatnot. The service manual acronym alphabet soup. CVRSS, GM's continuously variable road sensing suspension. Basically, you can see how simple that is, right? Fairly simple. You can just glance at that and figure out how it all works. Not a problem.
Is that them shocks you told us about that that somehow they put current to them and it makes the...
Yeah, we talk about that a little bit later in this presentation. Yeah, but they basically got some ferrous metal stuff in oil, and whenever you charge it up, it gets real tight and hard and turns into something stiff. It's pretty cool stuff. And then you got this KDSS, which is Toyota Lexus Kinetic Dynamic Suspension System. Everybody's wanting to come up with that. And, there's sort of a rundown on that. If you want to look at all those numbers and everything, you can see what's going on there. It's a nice little tangle web we're here. You got BMW EDC electronic damper control. That's a cool looking shot of that stuff. And so here we are with all of this different stuff that you got to try to figure out. Now, you got a Volkswagen DCCC. All right, now you might notice on some of these German cars, they've got each one of these components has got a code number like that. Whenever you see it on your schematic, it'll do that. And you might notice over here, you see they got N338, G343, GT6, and all of these things line up with one of those deals right there. So whenever you're troubleshooting something, if you don't know where to find this stuff, that's when you got issues. See there your J533, N3336. If that was a clearer picture, you could see those numbers. That's what it's going to look like in the shop manual when you're looking at that. That's the peculiarity of that German stuff. They've got that way of doing that. On BMW and Volkswagen are similar. A lot of the way that they do things, but electronically controlled shocks and struts, the systems fall into 3 basic categories. You got manually selectable suspension. You can change it yourself, and you've got your semi-adaptive suspension, and then you got your fully adaptive suspension. We'll try to touch on some of this stuff. You need to have some exposure to this stuff anyway. Suspension system springs have to compress and rebound with bumps and holes in the road surface. Back when they had wagons and stuff, when they just had axles under there and people were riding along, every time you bounced over a bump, it kind of compress your back a little bit. It really hurt. Then they would either put rawhide under there to make that not so bad, or they'd put springs on the seats. The actual seat would have springs under it and all that kind of things. That's the reason why they started doing that. The softness or firmness of the spring is known as the spring rate. My dad had a 66 Chevrolet pickup truck. It was a 3/4 ton, and it had the springs were set up under it. It had coil springs under it. It didn't have leaf springs under it, and half of the coil spring was wound really tight with the coils close together, and the other half of it was wound with the coils farther apart to try to give you the best of both worlds. It could carry a heavy load, but at the same time, it rode fairly decent. You know what I'm saying? So they had the same spring with two different spring rates on it. But if you could load it down, and those were by default, they were like overloads, because if it squished the spring all the way down so where the coils were all touching one another, that was as far as the truck was gonna go. I took it to the gravel pit one time and I told them I wanted a yard of gravel put in it. It was a real long truck, and the guy says, there ain't no pickup will hold a yard of gravel. And I said, well, put it in here until it runs over. And he put a yard of gravel in it, and I drove away with it. He was really surprised. But anyway, shock absorbers return it to its natural position quickly and smoothly without bouncing. And not only do shock absorbers control the compression of the spring, but they rebound too. Obviously, you know that. That's basic stuff. We've already been there. They gotta dampen the movement. They use fluid or gas forced through the holes in the shock absorber's piston. Now the little holes here, got these orifices and all. You can see this thing bouncing in there. Some of them are charged with nitrogen and that kind of stuff. How many of you guys have put shocks on that whenever that you had this nylon thing on them, you had to take them off, take that nylon thing off, and it would extend? You know what I mean? So that's bad. It's irritating to have to try to go back down with those too. Some of them don't have that. Some of them, whenever you take them out of the box, they're all the way compressed, and you put a wrench on the top of them and turn them like a quarter of a turn, and they come out. I mean, they don't all have, you know, nylon stuff on them. So, but anyway, the size of the holes determines the damping effect of the shock. If you change the size of the holes on the fly, you can change the firmness of it, right? That's probably what we're going there. So as a shock absorber compresses the piston and moves through the oil or hydraulic fluid, the energy never goes away. It changes states. Okay, that's the first law of thermodynamics. You know what you're talking about. The mechanical energy of the spring oscillations turns into heat energy, you know, so they get good and hot. If you hit something, you ever bust any shocks that were good shocks by going over something too hard? You did that?
Yeah.
What'd you do to them? It doesn't surprise me. What'd you do to them?
Drove through a ditch.
I figured if anybody had done it, you had. Okay. All right. The Rough Rider. All right. Now listen to this. You might not ever know this. I looked for this and couldn't find it. But Dave was talking about something. Apparently was out there earlier. There used to be an iSuspend app for your iPhone. All right, and you lay the phone on the passenger floorboard, drive the vehicle. As you press the start button and accelerate and brake as instructed, the app would record the spring oscillations via the GPS shock sensor internal to the phone. The data was then recorded in a graph form to help you determine if a customer's ride needed a new damper. In other words, it would make a graph about the shocks and how they were working. That's pretty cool. I went looking for that and couldn't find it. So don't, I mean, if you can find it, great, more power to you. I couldn't find it. All right, so passive, semi-active, and active suspension systems. What we're looking at next, the classification of suspension system. You got your passive, your semi-active, orifice-based damper, MR fluid-based damper. That's what you were talking about, right? Okay, active, slow active, active, and fully active. There's a whole bunch of different nomenclatures for that stuff. Depends on how deep they want to go into it. Now your orifice-based semi-active suspension, you got a motor and a motor shaft and a disc. This is drawn, somebody drew this on paint, it was a public domain thing. And basically when you turn that disc and it changes the number of holes that are open, that's how it's going to change it, see. And that's basically like some of your old Continentals and stuff that had that kind of thing on there. On the very top of it, it was a little flat deal and it had 4 wires going to it. 2 of the wires, when you reverse polarity, would move it back and forth. And they were hooked onto a little D-shaped shaft that was going down into the shock. And whenever it would turn it this way and that, it only had 2 positions. You know what I mean? And then basically there was 2 wires that was coming, and there's a voltage coming in, and if it shorted that voltage away, it would know it was in one position. If it, so basically you had a module that was looking to flip those back and forth. And what would happen is they went on there with them little Torx screws, and the ones back in the back under the package tray on top of the shock towers were pain to change. But anyway, I did some of that stuff too, and that's another little picture of that. All right, MR fluid-based semi-active suspension is what you got here. There's your MR fluid, like we're talking about, that magnetic fluid. You got an electromagnetic coil in there, you got a flexible bearing, accumulator, and those passages, and the coil wire. See the wires going down the coil in there? So basically, if you can load that thing up with magnetism, it's going to take you that. Look at this here fluid here. Magnetorheological fluid composed of oil and varying percentages of ferrous particles, 10 to 50 microns in diameter. What's a micron?
Very small.
Yes. You want to give me an exact, what's a micron?
Is it a millionth of an inch?
It's a millionth of a meter, is what it is. It's like a thousandth of a millimeter, right? So now, does everybody know what a micron is? When I say at the end of the presentation, what did you learn? Are you going to be able to tell me that a micron is a millionth of a meter, right? Like, whenever you talk about a fuel filter or a filter that's, there's a 25 micron filter, they're basically measuring the, the gaps in the filter, which that'd be pretty fine, right? All
How
right.
do they measure that?
Huh?
How do they measure that?
They've got little teeny tiny plastic balls that are that size, and they see how many of them will go through there and how fast. And each one of them, like a micron, it's just a little spherical, it looks like powder to you, But basically, they determine how much of that will go through there, but it's little enough to go through just about any kind of filter, the little particles are. As a matter of fact, steel, iron, rust is in such tiny particles that it will go through a fuel filter
Yeah.
in some cases
Stop
and
up.
stop up injectors. You seen that happen before? I mean, it's
Carburetors.
that little, So you vary the magnetic field strength and it's got an effect of changing the viscosity of the fluid. You can see how that would work. It's not that complicated, right? All right. Now then, active versus semi-active. You got lower implementation cost on semi-active, lower power consumption, doesn't take as much to keep it going, easier to control, simpler design, and it's easy to put on there if you're just going to put you some on there, right? Can you imagine doing that? You put different shocks on there, they got little actuators on the shocks, you run your wires out there, and you can basically, put some on there your own self. All right, so active versus semi-active. The active system's got a wider range of force, that means it's got more that it can do, right? No force or viscosity constraint. Can achieve better vehicle dynamics, and the disadvantages are it uses a lot of power, higher weight to power ratio, expensive. Major modification has to be done before you put active system into the existing vehicle. And I never have been much of a mod person anyway, so So, you got manually selectable suspension. You got a set of dampers, electronic solenoids. That's like we were talking about earlier. Response to an on and off command. That's on your switch right there. BMW's EDC. On GM trucks, there's a switch that might be titled Ride Control Firm. Gives a stiffer ride to reduce the bouncing when you're pulling a trailer. Okay. When you pull a trailer sometimes. You ever drive a truck that had a really, really heavy load in the back or had a really heavy trailer behind it?
And the headlights shine up in the trees.
And it feels like the front tires are barely touching the road. You ever seen it? It just feels strange, when you're driving something like it. You can turn the suspension up. It helps you with that kind of thing. All right, so your major components of an electronically controlled semi-adaptive are body position sensors, steering position, body acceleration sensors. What does a body acceleration sensor do? What does it need to know? What is it going to tell you? What's a body acceleration sensor telling you that nothing else will tell you?
Tell you how fast you accelerate.
Well, it tells you that, tells you how fast you're stopping, tells you how fast you're going back and forth. Pitch and yaw. Yaw is like, this, and pitch is like that. So basically what you want to do on that. Suspension component acceleration sensors, which is active suspension. Then you got vehicle speed sensors, controlled dampers or suspension actuators, and electronic control module. Obviously you got electronic control module, you're always going to have one of those. All right. So you got semi-adaptive suspension. The major components are, and I think I need to back up one on that. Body position sensors, steering position sensors, not a whole lot different there. Suspension component, pretty much the same. All right, except the way that it acts. And there's your little GM schematic right there that you can look at. Anytime you see a GM schematic, you'll typically recognize it because it will have these two little boxes up at the top. It's like location and description and all. All right. So, road texture detection, direct and indirect body position sensors. All right. One of the things that it's looking at is it's basically looking at how bumpy the road is, and that kind of thing. So, electronically controlled suspension systems got to be able to detect the road surface in order to determine if the damper calibration needs to change. It's got feedback. And these computers gotta have feedback, they gotta be able to look at something and see, how am I doing, right? Okay, so, if this will pay attention to me. If it goes on, well, let me back up, I think I clicked it 2 times. Okay, yeah, okay, let me make sure I got it right. If it goes on for any period of time, a passive TPMS system can light a low pressure telltale on the instrument panel cluster. And you know, there's a height sensor right there, and all that, see? All right, so, let me come on. MagneRide, been around, introduced since the late 1990s, been around for a long time. But it's used in non-automotive vibration reducing applications like washing machines. Let me stop for just a second here. I mentioned this to somebody the other day. There was a guy, when I was pumping gas in 1974, I guess it was. They pulled up out at the gas pump one day. We had a full service gas station, and I went out there, and he was checking the air pressure in his tires. We had a free air out there at the pump like you used to have at gas stations, you know what I mean? I think if I opened a gas station nowadays, it was gonna be like a regular old-time gas station. I would have full service, and I'd have free air and water at the pumps. You know, instead of having to thumb quarters in there to get an air for your dadgum tire. One way or another, this guy was checking his air pressure, and I said, what is that tube you got around the inside of your tire? He said, that balances my tires while I'm driving down the road. And he made it out of water hose. You know, the way those rims were made, you know, basically there was a place where he could put those in there and they wouldn't come out. You know what I mean? They made them big enough to where he could just snap them in there. And I said, well, how do you make that? He said, well, I get that piece of hose, and you know, he basically had cut it really nice and he put it together so that it made a hollow tube. And he had filled it up about, as I remember this, now this was a very long time ago. If you do the math, in 1974 was quite a few years back, 41 years ago. But anyway, I said, he says, I fill it about a third full of shot, like you put in a shotgun shell. And he says, and if the air pressure is right, when I'm driving down the road, it automatically balances the tires as I drive. He says, because the shot goes to the light side of the tire, just because of the dynamics of tire rotation. And that seemed like a crazy thing to me, and I kind of filed that away for all these years. And then me and my wife, we got a Maytag Neptune washing machine. And that thing would spin clothes, you know, these front load washing machines, how fast they spin. That doggone thing spins like a jet taking off. Ooh, just scream up there. But it never, no matter how it was loaded, it never vibrated. Never. You couldn't even feel it hardly when you put your hand on the machine. And I recognized as we were watching the video that came with it, that it had a tube on the back of it that was loaded with weights, just like that guy put in his tires. Because they said sometimes when you turn the drum, you may hear this stuff making racket. That doesn't mean there's a problem. That's what balances the drum. Interesting concept, you know. I don't know where that guy learned that. He must have been some kind of engineer. But anyway, it changes its nature at the flip of a switch. It's even been seen promised in the field of personal body armor that can flex with the wearer under normal conditions and become as stiff as a metal plate when a firefight ensues. You know, like you're moving around, no problem. When you got a firefight, you just flip your switch and all of a sudden you got body armor that you didn't have before. You see what I mean? That's a pretty cool idea that they come up with. All right, so fully active suspension. If you're working on one of these, you need to make sure you fully understand the difference of these systems. How many times have I told you to go to description and operation when you're working on an unfamiliar system? Go to description and operation. You will find out things that'll save you a lot of time. You know? And I've sometimes when I would be dumb enough to try to fly in there and figure something out on the way, because you know, the younger you are, the more you tend to sort of fly in there and figure things out. Whenever we get some kind of a piece of equipment or something at the house, my wife reads every word of the instruction manual. Me, I want the quick start guide. Throw that book away. Give me the big pictures. I just want to plug it in and start using it, you know. But she knows stuff about this stuff that I don't know. I just lost a button. Whose fault was that? All right. So, any system that's not fully active reacts to road forces by responding with resistance. Now, fully active suspension systems have been attempted in production vehicles for a long time. For long years by numerous manufacturers, and the volume's been low because they give trouble and people don't like it when they don't work right, because it's really kind of hard to make them work right. You know? Now, So, get some service issues here. Visual inspection is still in order. You're gonna see that same information at the end of this thing that you just saw, so don't think I accidentally duplicated a slide, even if maybe I did. Okay, visual inspection, in order after a road test, corner bounce test. If there's any signs of fluid leaks around the damper, physical damage, if it's bent, whatever, worn or broken, wire harness connectors, you may need to sell some dampers. Now that right there is your little changer. See that? This is a little thing it turns, and that turns it, basically. Or that basically on that one there, excuse me, that one there is one of the magnetic ones, is what that is. That's not the turner, but it looks real similar to the other one I was talking about. Body position sensors, miscellaneous connections, you got all these wires, you're gonna have weak links, you know? So they're basically potentiometers, like TPS sensors in a harsh environment. My rule of thumb is the component that is in the most hostile environment and is working the hardest is usually the one that fails. Like in a gas gauge system, it's gonna be the one in the tank, because it's, you know, got all those temperatures, it's going up and down all the time and all that kind of stuff. Or anything that's out there that's bouncing around in the weather. Usually if the horn doesn't work, it's because the horn's gone bad, because it's out there and all of that. So anyway, linkages and mounts, if there's any single, most likely cause of trouble code or other out of control complaint on one of the systems, it's gonna be these kind of sensors here, these delicate sensors that put out this little whisper of a voltage and all that. Communication with other systems, outside of the dampers having problems, broken body position sensors, hardware, you got module hardware, software issues, sometimes you'll do a reflash. Read the DTC, follow the chart, always look at issues that pertain to the other systems. Now I like to, whenever I'm looking at DCT and following a chart, I like to have a wiring schematic laying here, description and operation, read the DTC and follow a chart. If I read the chart through, I can tell what they're wanting me to do and figure out kind of which way I need to head based on, you know, the function. And that's what you think. All right. Other systems have to provide information to the system. Before you set the rack and fire up your impact wrench on a vehicle that's got electronic ride control, connect an OE level or factory scan tool to the DLC and give the total vehicle a thorough DTC check. You ought to see that new scan tool I bought, by the way. That thing is slick. And I'll have to show that to some of you guys here shortly. Do the full scan when working on one of those. Sometimes I'll fuss at you guys when we're going after an engine control problem like a check engine light and everybody wants to scan all the modules, and then that way you prop your feet back and you wait for about 20 minutes while it scans all the modules. I like to go right to the module I'm looking for and all that. But these are high-tech systems that require high-tech techs. Are you guys high-tech techs? You're not high-tech techs. Okay. All right. Now, when I click that, you got a B1, that's what it says. And that's the end of that slideshow. All right, I'm gonna tell you guys about another